As I said earlier, today we're just doing a review lesson of some of the topics we've been working on recently. So your worksheet will have just extra practice on a variety of the more recent topics. I do want to take a few minutes to talk about expanding and condensing logs. We've done it a tiny little bit, but we're going to do messier ones that have more than just two steps in them, or two things that we need to combine. So our starting place is to remember our logarithm rules. And when it's written out, where it's one thing plus or minus another thing, so it looks longer, that is the expanded form. And the shorter one, where we put them all together as just one log, is the condensed form. And we can go either way. If you start off with log base b of m plus log base b of n, as long as these bases are combined, you can take the two arguments and multiply them together and just have one log in the condensed form. Or you can start with the log of two things that are multiplied by, and for some reason you need to expand that out. So you can take the log of the first one plus the log of the second one when you expand it out. Similarly, the quotient rule, if you start off with a minus sign in between two logs that have the same base, you can combine them as just one log with that same base. Whichever one was positive goes in the numerator. Whichever one had the negative out in front, that one will go in the denominator. Or if you start out with a log of one thing divided by another one, you can split that up into two logs as long as you subtract what you get in there. And the third rule with working with logs is the power rule. And I'm not all that sure which one's really longer or shorter than the other, but it goes both ways. If you have a number out in front of a log and you're trying to solve a log equation, so you know you've got to get it log equals, not 5 log equals, not 7 log equals, you can take that number and make it be the exponent in that argument. Or if you start with something where you have an argument and just the argument is raised to the power, you can bring that number out in front. So those should look familiar, right? Thumbs up, thumbs down. Okay, this slide kind of builds on that just a little bit with a couple of extra things. Log base a of 1 would be 0. Because if I said, I don't know what the log base a of 1 is, so I'm going to name it x, and then that means exponential form, a to what power is 1, anything to what power is 1? So the exponent would have to be 0, which means this would have to be a 0. So log base 5 of 1 is 0. Common log of 1 is 0. Natural log of 1 is 0. So you may use that to simplify in some problems. We've also done some where we've said, oh yeah, log base a of a to something. The log base a cancels. So this would have been log base a of a to the first is 1. Log base a of a squared is 2. Log base a of a cubed is 3. Log base a of a cancels and just leaves whatever used to be the exponent. And this is the product rule and the quotient rule that we just reviewed, as well as the power rule. So kind of some steps if you are expanding. So you're starting with a short form and you want to write it out. If you have square root or cubed root, rewrite that as something to the 1/2, something to the 1/3, so you'll be able to use that power rule to simplify it. Use the product and quotient rules to write it out as addition and subtraction because you're trying to expand it out. Move any exponents out in front and then simplify any places that you can. So far, so good? So let's do a couple of messier examples than you're used to seeing. When it says expand, it usually also says so that it is a log with all of the arguments being linear, so that you no longer have exponents in any place and you don't have any fractions in there, and all of that. So anybody have an idea as you look at that and you think about those properties that we were talking about? Anybody have a good idea of a starting point? Hopefully some of you do. Do we see a product or a quotient? Do we see anything we could split up? We want to try to start, we don't have any square roots, so we don't have to do that guideline, but we would like to look at things that are products or quotients and write those as as logs that are added or logs that are subtracted. Thanks, Ethan. What are you thinking? Of 5. Excellent. Thank you so much. So far, so good. But I still have exponents. I still don't have linear things. So I still have to do a little bit more work in there. I need to be a little bit careful. Is this the same as my whole argument to the 4th? So I cannot bring that 4 out in front yet. However, could I also use my product rule? Is that the log of one thing times another thing? And when I split up a product, what sign do I need to put between the logs? So that one I could say is log base 2 of 8 plus log base 2 of x to the 4th. And then I have my minus log base 2 of 5. Is it linear yet? Leah, you just shook your head. No, you're correct. What's wrong still? The x to the 4th. And how do I fix an x to the 4th when that's my argument? Wyatt? So we're going to move the 4 in front of the log. So we could say log base 2 of 8 plus 4 log base 2 of x minus log base 2 of 5. Does that make sense? You don't, yeah. No, you'd have to make it log base 2 of 8/5. And we're not trying, you'd have to go back to, oh, this is 8/5 times x to the 4th. However, there is a simplification we could do. Before I talk about that, though, I'm going to talk about a little bit shorter way to do some of these. If you start off and look at, oh, I've got a log of a whole bunch of things. Right here, I'm going to say this is 8 times x to the 4th and over a 5. Any of the ones that are in the numerator, when I split it up, when I expand it out, will need a plus in front of them. Anything in the denominator, even if I also had a z to cubed or something else down here, anything in the denominator, I'd write out with a minus in front of it. So I could have gone straight to this step, log base 2 of 8, a positive out in front, log base 2 of x to the 4th, a positive out in front, log base 2 of 5 with a negative out in front. And this one just happens, we could simplify log base 2 of 8. Can anybody tell me about log base 2 of 8? I am asking you the question. Log base 2 of 8 equals what? So think about changing it to its exponential form and figuring out what that has to be. Ada? y. This would be 2 to the y is 8. So y would have to be 3, but y was just a name I made up so I could simplify it. I could say this is 3 plus 4 log base 2 of x minus log base 2 of 5. Anybody with a question there? Okay, let's do another one where we expand, and then we'll do some where we condense. All right, so I've got a square root, and remember we said one of the things would be to rewrite that instead of using a square root sign. What would I do with the square root? How can I write square root as an exponent? What would I do, Austin? When we just have square root equals, not log of a square root equals, if it's just square root equals, yes, we square both sides to get rid of it. I'm not getting rid of it yet. What's another way, instead of using the square root symbol, what exponent can I use that means square root? 1/2. So that's xy to the 1/2. And there's more than one way you could proceed next, but somebody give me an idea of what we might do next, trying to expand that out. What are you thinking, Nicole? It is a log base 10, yes. Well, the log always has to come first. And yes, you are exactly right. You are doing a couple of steps at once there. So I'm going to split it up just to make sure everybody keeps up with us. And then we'd have something else we could do after that. So one thing we could do is to say, well, that argument means x to the 1/2 times y to the 1/2. And then Nicole was saying, oh, we're multiplying here. So we can write that by adding the two logs. So it would be log of x to the 1/2 plus log of y to the 1/2. I still got exponents. And I want to get where I have linear arguments. What do I do with the halves, Griff? Right now, they're exponents on my arguments. What can I do with them? Jack, can you help? If you have an exponent, you can bring it out in front. So we could say that that is 1/2 times the log of x plus 1/2 times the log of y. Anybody with a question there? And now I don't have any more exponents. Everything's linear. Everything has degree 1 in there or less. All right, condensing means we want to smash them together. Yesenia? Yeah, there'd be more than one way. You could factor out the 1/2 in front if you wanted to, but there's nothing more you can do. The important thing is these logs are either just numbers or just variables that have no exponents, and that's what we're trying to get to. All right, now we want to put them together. Going back to my rules at the beginning for just a moment, if I want to put them together, I have to have 1 log plus 1 log, not 3 log, not 5 log. I can't have numbers in front of them, same if I'm subtracting them. So I have that problem on this next example. I can't put them together yet because I have those numbers in front of log. What do I do with the 3, with the 5, with the 2? Abby? We can make them be exponents. So this is the log of x cubed plus the log of x to the 5th minus the log of x squared. Do all three of those logs have the same base? Any of them that have the same base, I can squash together. So what I'm going to do is I am going to look for the ones that are positive and put them in the numerator. So this is going to be the log of x cubed times x to the fifth in the numerator, because if I have a log plus a log, I put them together by multiplying them. This one over here, however, had a minus or a negative sign in front of it, so it needs to go in the denominator, because the log of this minus the log of that I'd have to put together by dividing. So I put my x squared down here. That was the trickiest step. Now it's back to, I don't know, pre-algebra. What is x cubed times x to the fifth? What is x to the eighth over x squared? So that becomes the log of, but this whole argument simplifies to x to the sixth. And one last example, and then you'll just be working on homework. Thoughts here? Cooper, what are you thinking as a first step? That sounds excellent. Let's make the numbers that are out in front become exponents. So we are working with the log of x to the fifth minus the log of y to the 1/2. Do these logs have the same base? That means, yes, we can put them together as one log with still that same base. What do I need to do with the x to the fifth and the y to the 1/2? I was subtracting the logs. Ethan? This one was positive, so it goes in the numerator. This one has the negative in front of it, so it goes in the denominator. And there is our condensed answer. Questions? They do have the same base. They're both log base 10. The variables are different. On the one before, I put all of the x's together so that because they were all x's, so I could just write x to 1 power, and I needed to do that to simplify it. Now I have different letters, so I can't also put them together.